Alright, welcome back. Mr. Martin here in Mr. Martin's Math Corner. We are talking 8.3, graphing piecewise functions. And in order to do this, we need to understand what a restricted domain is. And we also need to graph these pieces. So make sure you got a ruler or straight edge of some sort, because you know I like pretty lines. So things to know, a piecewise function, this is a function that is defined by at least two, so we need two or more pieces, each of which applies to a different part of the domain. This is a word we're going to see all the time. It's very important to understand what that is. Remember, those are our x values. This can take on a variety of forms: linear, quadratic, square root, absolute value, exponential, etc. There are many more, but for this section we are going to be using some linear functions. Alright, so we also are talking about adding a rule or a restricted domain, and this is what actually cuts those functions into its pieces. Alright, so we do need to recall slope-intercept form. Remember, this is our y equals mx plus b, and it's important not to just know it, but to know what these parts mean. Remember, this m is our slope, and this b is our y-intercept. Okay, so we're going to be using this to graph these linear functions. Alright, and then we also need to know inequality signs. Remember, if it is less than, greater than, these are going to be our open dots, so you need to know the dots. And less than or equal to, greater than or equal to, these are our closed dots, solid dots. Very good. So this is some stuff you're going to use. You're also going to use, I didn't write it in here, but we're going to use ordered pairs. Remember, we got x and f of x. This is the same as x comma y. So you kind of need to know. And remember, this is input and this is output. So this is all very good and well. We have learned these before, so you should know them, but it's good to kind of think about them as we go through this section. And then I got this note here that says graphs should not be on top of each other. And you're going to see what this means as we get through some of these. But I want you to draw this little checklist here. What this means is you should not see a solid dot over a solid dot. This is a no. Don't look at that. You can, though, have an open dot over an open dot. And you can have an open dot over a closed dot, or vice versa, closed dot on top of an open dot. This would be okay. This is the only one we don't want. We don't want closed dot over closed dot. Alright. Let us jump into learning how to do these. Alright, so this first example, it wants us to recall graphing lines and then adding a rule, restricted domain. I got this f of x equals -4, g of x equals -x minus 3, and then I got h of x equals 2x minus 2. Remember, these are all in slope-intercept form, so you should be able to graph these. I want you to pause the video right here, graph all of them, and then come on back. Alright, welcome back. So I got my lines here. I did red, green, and blue for you. So this first one, remember, this is just like y equals -4, so we just got this straight line going across. This one starts at -3, has a slope of -1, so we're going down 1 to the right 1. You can also go up 1 and back 1. And then here we got a +2, so we're going up 2 and to the right 1, up 2 and to the right 1. Alright, so now that we have these graphs, it says down here that we're going to create these rules for this function. And we want to use inequalities to write these rules. Okay, so my first one tells me if x is greater than -7 and less than or equal to -5. So remember, if I'm in between two numbers, that means, let's do this in purple down here. That means my x has got to be in the middle. So I'm going to be greater than -7. So there's no underline here. I'm greater than negative 7. Remember, we read with the variable first, x greater than negative 7. And then I'm less than or equal to negative 5. All right, so for this first graph, what this is telling me is that I only want this graph for these x values, for this domain. This is my restriction, my rule. So I have this entire graph, but I want between the x values of negative 7 and negative 5. So if I look for negative 7, and just imagine that I'm going down here, okay, and then also between negative 5, I only want the graph right here. All of this other graph I can get rid of, but I also want to think about my inequality signs, because this is where I need to use these guys. All right, so at negative 7, I need a open dot because I'm only greater than negative 7. I'm not going to include it, so I'm going to put an open dot right here. Okay, and then at negative 5, I'm going to need a solid dot because I'm going to include negative 5. And then I can get rid of the rest of this graph because I only want this one piece right here. So I'm just going to simply erase everything else except for that section right there. Boom. So this is what I'm looking for here. All right, and then my next piece, okay, it says if x is greater than negative 5 and less than or equal to 0. So remember, my x is in the middle, greater than negative 5, and then less than or equal to 0. So if I look at negative 5, remember, I'm using just up to this part right here. And then at 0, just up to this part right here. So this is the only piece of the graph I want. So I'm going to cut out at negative 5, I'm going to use a open dot. And then at 0, I'm going to use a solid dot. And then I'm going to erase the rest of this graph right here. So if you're going to be doing erasures like this, make sure you draw lightly so it's easy to erase. And we can see what you are talking about. Boom. All right, and then last but not least, the last one says if x is positive. Well, how can I write an inequality? It didn't even give me a number. But what are positive numbers? They're all greater than what? Greater than 0. And it didn't say greater than or equal to 0. I just want all positive numbers, so that means they have to be all numbers except for 0. Okay, so I am looking at a open circle at 0. And then I want everything bigger than this, so everything to the right is going to be included, and everything to the left is going to be erased. So now I got my 3 pieces. Okay, so this is what adding that rule or restricted domain does to my graph. And then now down here, it wants me to graph all 3 of these. So if I have my piecewise defined function, let's write this. This is how they are going to look. Okay, so we used f of x, g of x, h of x. I'm going to use p of x, because we all shop at the PX, yay. We're just going to call it p of x, and then we're going to use one of these big squiggly brackets. And then we're going to write our functions here. So we got negative 4, and then we separate these by a comma. This one's going to be negative x minus 3. And then we're going to put our comma, and then we got 2x minus 2. So here we have all 3 of our functions, but now we want to write the restricted domain next to them. So this first one at negative 4, our domain is negative 7 less than x less than or equal to negative 5. And then negative x minus 3 is going to be between negative 5 and 0. And then here we're going to have x greater than 0. Okay, so this is what you're going to see when you are given a piecewise defined function before graphing it. Okay, and the easy way that we can graph this is we have all of our parts right here. So let's go ahead and do that. We had a line from, let's do this in red. We have our line from -7 to -5 at -4. So -7 was open, -4 was closed, and this might look a little ugly. And then our other one was from -5 to 0. So we started at up here at 2, and then we went to 0 at -3. And I'm just going to draw this line here. And then our last one was at -2. We had an open circle. And this one went on and on and on forever. So as you can see, based on our rules from before, this little note, okay, we should not have solid dots on top of each other. We can have empty dots or empty dot and solid dot. So let's take a look. Did we follow that note? So here I got an empty dot, there's nothing above it. I got a solid with an empty above. I got a solid with an empty above. Okay, so this still makes a function. Remember, if you have two solid dots, that means you have two different y values for the same x value. And remember, that is not a function, so we are still dealing with functions. So based on our graph here, we are still dealing with functions. All right, example number 2. So we're going to walk through one where it's the graph and erase method. This is where it's useful to know your y equals mx plus b. Some people find it really helpful to just graph entirely and then erase the parts that they don't need. So let's go ahead and start with this one. So we would start at +7, and our slope is 1/2, so we would go up 1/2, down 1, back 2, down 1, back 2. And remember, it's always helpful to put as many points as you can so you can draw a nice graph. And then it says we only want between -6 and -2. So -6 is right here. So I'm going to erase at -6, and I'm going to erase past -2. But I need to remember what kind of dots I have. So at -6, and sometimes it's helpful to do this just to remind yourself, oh, I'm going to have open dot, I'm going to have a closed dot. So at -6, I'm going to have open dot. At -2, I'm going to have a closed dot. All right, and then my next one starts at +2. I have a slope of -1/2, so down 1/2, down 1/2, down 1/2, down 1/2, and we can go back the other way. Up 1, back 2, up 1, back 2. And I know I'm not going to go past this graph, so I'm just going to stop right here. I'm going to draw my line because I know I'm going to have to erase some stuff. And can I do it? Alright, not bad. And then this one is between -2 and 4. So this sign tells me I have an open dot. This sign tells me I have an open dot. So I am going to erase up to -2. And then I'm going to erase up to +4. And then I'm going to draw my dots. Open dots. Open dot. And so far so good, right? Closed dot over open dot. Okay, my last one, we start at -2. I have a slope of 1/4, so up 1/4, up 1/4, down 1, back 4, down 1, back 4. And we can draw this line. And function, I need to erase it at greater than 4. So 4 and above is being kept. I am erasing everything before that. And I also have a solid dot right here, so I'm going to use a solid dot. So boom, I got my piecewise function graphed. Remember, I do not have two solids directly lined up vertically, so I am good to go. This graph looks good. This is how we can do the graph and erase. Okay, I do want to show you another method, because if in fact you do not have enough room to fully graph by using slope-intercept form, it might be rather difficult, and there is an easier method so you don't also have to do all that erasing. And this is where we do the substitute values method. So we got this first function up here, 3x plus 14. If we look at our graph, it goes to 8, so there is no way we can plot our y-intercept of 14. So this is where we would want to use these substitute values. Okay, and the way that this works, let's go ahead and put all of our dots first. We know that we're going to have an open dot. We know we're going to have a closed dot. We're going to have an open dot. We're going to have an open dot. We're going to have a closed dot and a closed dot. Okay, so basically what we want to do is we want to create a XY table for each of these functions. So for this first one, what we're going to do is we're going to plug in this value of -6 into x so we can see what our y value is equal to. Remember, this could be y or f of x. It's going to be the same thing. So if we plug in a -6 here, and one way to do this, let me go ahead and pull this up for you guys. Alright, here I got my calculator handy. One way we could do this is we could type in all three of these functions at once and use the table function. It's going to make it so much easier. So let's type in this first one. We got 3x plus 14. And then the second one, we got a negative. And then remember, to do a fraction bar, we hit alpha y equals. And then we choose option number 1. And we're going to do 1 over 4. And then we're going to type in our x. And then we got -2. And then our last one, we got -6x plus 30. Alright, so we got y1, y2, and y3. Now when we go to our table, if we do second and table, okay, we're going to see all of these values here. Okay, so for our XY table, we want values for -6 and -4. So if we go up to -6, okay, when x is -6 for my first function, y is going to be -4, and when I have -4, it's going to be +2. So let's go ahead and write those in, -4 and +2. So when x is -6, y is -4. And when x is -4, we have a, what was it, +2? +2. So let's put that in, +2. So now we can go ahead and graph. We have our first point and we have our second point. So we can start at -6, -4, and that's going to be a open dot. And then we have our second point at -4, 2. So -4, 2. And it looks like we're going to have a closed dot. And if you check the slope, it should work. Let's go up 1, 2, 3, 1. 1, 2, 3, 1. Boom. Look at that. And we're going to draw this line right here. Alright, so let's go ahead and do our second XY table. So we have XY, and we're going to do -4 and 4. And we're looking for our Y values, and this is our second row. So when x is -4, we get a -1. Remember, we're looking at y2 now. So we get a -1. And then when it is +4, let's tab down, we get a -3. So these are our 2 points. We got -4, -1, and that is a open dot. And then +4, -3, and that is also a open dot. And then we can just draw our line. Alright, and then our last one, we need another XY table, and we're going to do 4 and 6. And now we are looking at the third row. So when x is 4, we have a +6. And when x is 6, we have a -6. So at 4, 6, we have a closed dot. And then at 6, -6, we also have a closed dot. And then we got this line going down this way. And yours should look a lot straighter than mine. Please forgive that line. I know I said I like pretty lines, but off the cuff, this is all I got for you. And we do want to check, do we have any closed dot over closed dot? We do not, so we are good to go. So I think this is a lot more easier to do, and also depending on what your y-intercepts are. Remember, if they're way off the graph, like +30 would be kind of hard to do. You might need to use this method, so it's very good for you to learn how to do it. And for example number 4, you got one to do all on your own, so go ahead and pause the video here, come on back, and check what I have. Alright, welcome back. So here's my graph on the right. As you can see, I did these little XY tables. It's really quick, especially if you got some good mental math. Just multiply to the fraction, maybe a little bit of addition or subtraction there, and you got those values, write them down. Really easy to draw these graphs. Alright, so that is it. Definitely do the practice. These take a little while to get good at. If you need help, always here to help. Ask a friend, ask a teacher, ask a family member. Somebody's there to help you. Hope you enjoyed the video. I'll catch you on the next one. Peace out.